Hi everyone. So today let us read about the threshold and confusion matrix. So threshold is similar to what is in a classification uh, problem that we are talking about in the logistical regression model. Like any of the uh, like a small spam email detection. Let's for example spam email detection. So let's say the answer for the output for a spam email is that we want whether that particular email is a spam or not. So when a particular model is employed to check for this that this model is this email is a spam and this email is not. So what is a particular threshold? Since the model produces a probability output of let's say 0.5, 0.8 to 0.2, 0.3. So what is the threshold that you decide that below that threshold we will classify this email as a not an spam, but above this threshold we will classify this email as a spam. So this is called classification threshold. You see, you choose the threshold probability called classification threshold. Examples of which examples with a probability above threshold values are then classified assigned a positive class. Positive class will be the spam class you are testing for, and examples with lower probability will be assigned to a negative class or the alternative class, and in our case not spam. So there is an interesting, I think, yes, interesting detail is that what happens when you when the model predicts the exact threshold. For example, if the predicted threshold is equal to the classification threshold, so what happens in that case? So there is take an example of Keras library which predicts the negative class. So if the threshold is equal to the threshold is equal to the predicted score, then the classification or the prediction goes to the negative class. But in our different tools, they may choose to uh, classify it differently. Okay, while 0.5 might seem like entity threshold, it's not a good idea if the cost of one type of wrong classification. Also, it depends on a kind of a use case. So, how sensitive or specific that use case is when you decide the classification threshold for a particular model. Okay, so what is a confusion matrix? So, confusion matrix is quite confusing. It is actually the output. There are four possible outcomes for each output in a binary classifier. So, since there are four possible outcomes, we can put that into a matrix. And for spam email, so this is the 2 cross 2 matrix. Predicted positive, predicted negative, actual positive, actual negative. Now, what is predicted? What is predicted? So, predicted is the value. What is the model output? And actually is our dataset result. What is the actual result in the dataset? So let's take the first one. What is the true positive? True positive is spam email, which is actually a spam, and also model predicts it a spam. So that is a actual true positive. So this is a true positive. Spam email correctly identifies or classified as a spam, where both the prediction and the actual both are positive. What is actual negative? Where a not spam email is classified as where a not spam email misclassified as spam. These are legitimate emails that wind up in the spam folder. So this is false positive, where a not an spam folder email is classified as spam. So where prediction is wrong. So if prediction is correct and actual data set is correct, and that is a true positive. And in the case where a data set is correct, where data set is actual or correct, but prediction is negative, So that is a false positive. And in the predicted negative is spam email misclassified as not a spam. These are spam emails that aren't caught by the spam filter and make their way into the inbox. So actually they are a spam, but by prediction they are predicted as false, that they are not a spam. And true negative is not spam email correctly classified as not a spam. These are legitimate emails that are sent directly to the inbox. Okay, moving on, we can see what is the effect of threshold value on the uh, true positive and false negative. So as we increase the threshold value, you would see, okay, if we increase the threshold value, you see that true positive is increasing or decreasing, I would say decreasing, and false positive is decreasing. But false negative and true negative is increasing. Why that is the case? Because as we increase the threshold, so the output or the most of the email will be classified as negative, because we are creating we have put on the criteria very high for the email spam email. So that is why most of the email will go to the predicted, will be predicted as negative. And also it depends on the data set, like it is a separated, unseparated, imbalance, what type of data set is this. So separated is where positive examples and negative examples are generally well differentiated. Unseparated is many positive examples have lower scores than negative examples. Imbalanced is containing only few examples of positive class. So this is a few of the questions. And again, then we can move to the accuracy, recall, precision, and related metrics. So these metrics are used for evaluating a particular model. Okay, let's first try to solve this. So imagine a phishing malware classification model where phishing and malware websites are in the class level true and harmless websites are in the level class level 0. This model mistakenly classifies a legitimate website as malware. What is this called? This is called a false positive. Why? Because the misclassification prediction is wrong, but our data is correct. So it is a false positive. A negative example, legitimate site has been wrong classified as positive example. Next question is, in general, what happens to the number of false positive when the classification threshold increases? What about true positives? Experiment with the slider above. Okay, let's experiment with the slider. What happens to the true positive? So you see, if we increase the slider threshold, true positive decreases. And also false positive is 0. Of course, it would be 0 because we increase the threshold. Now you see, if you lower the threshold, then both true positive and false positive increases and negative cases decrease. So let's answer you. Both true and false positive decreases. As the threshold increases, the model will likely predict fewer positives overall. True or false doesn't matter. It will predict fewer positives because you have increased the threshold. Like example, threshold of 0.99 will only label an email as spam if it considers the classification to be at least 99.99% likely, which means it is highly unlikely to mislabel a legitimate email, but also likely to miss actual spam email. So be very cautious. Also, next question is, in general, what happens to the number of false negatives when classification threshold increase? What are the true negatives? So we have seen that. Okay, let's take when we increase the threshold. Let's say what happens? False negative increase, true negative increase, both increase. As the threshold increases, the model will create more negatives, both true and false. Okay, well, let's see the evaluation metrics. So these metrics are based on the rates of true positive rate, false positive rate, based on that example. So what is the accuracy? Accuracy is correct classification upon total qualification. Correct classification, true positive, true negative. That is the correct classification. What is the total classification? True positive, true negative, false, all the four possible outcomes. So that is accuracy, proportion of all classification that are correct. Whether positive or negative does not matter, because whether it is a positive or negative, both are correct. So perfect model will have zero false positive and zero false negative. Therefore, an accuracy of 1 or 100%. So what is a true positive rate? False positive rate. True positive rate is also called recall. True positive rate is of course true positive upon true positive plus false negative. All actual positives is probability of detection. What is a false positive? False positive is false positive upon all actual negatives. Incorrectly classified actual negatives upon all actual negatives. A perfect model would have zero false positive and therefore FPR of 0.0. What is the precision? Precision is correctly classified actual positives upon everything classified as positives. So again we can see how matrix moves. First the slider, see if we move, the precision is 1 but accuracy and recall decreases. Why? Because it is based on accuracy and recall is based on the false positive. What is the correct classified actual positive? Correct classification. So that is why if you increase the threshold, accuracy and recall will decrease. See, accuracy and recall will decrease, but precision will be 1. Precision will increase. And if you lower the threshold, then accuracy and precision will increase, but recall will be 1. Okay, now when to choose which matrix? Accuracy is a rough indicator of model training process and convergence for a balanced data set. For model performance, use only in combination with other metrics. Avoid for also. Okay, so the matrix we choose is contextual and depends on the kind of database and data set we have. So accuracy, avoid for imbalanced data set. Consider using another metric. What is recall? Use when false negatives are more expensive. Okay, false positive rate, use when false positives are more expensive. Precision, use when it is very important for positive predictions to be accurate. These are the three questions. Okay, that's all, and next we will study ROC AUC, and that's all. In the next video maybe I can take on different other question, or we can study this further.